Hello, my dear SSLC students. Your exams are approaching. So, solve more and more question paper. Here I am going to solve model question paper number 3, which is issued by Karnataka School Examination and Assessment Board. I am going to solve each and every question with the detailed solution. So, please like, share, and subscribe and support me. Now let us solve the multiple choice questions. There are 8 questions which carry 1 mark each. The first question, the product of prime factors of 90 is. You need not do any mathematics here. By looking at the options, so easy. You can say that whether it is a product of prime factor or not. Observe the first option 9 into 10. Both numbers are composite numbers, so this option is wrong. Option B 6 into 15. Both are composite numbers, not prime numbers. Option D, here 15 is not a prime number. Option C, observe all the numbers are prime numbers and the product of 2 into 3 into 3 into 5 is equal to 90. So option C is correct. The second question, if the lines represented by the linear equation a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are parallel lines. Listen carefully, read carefully. If the lines are parallel lines, then the equation is this one. Option B is correct. A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. Option A represents coincidental lines. Option C represent intersecting lines. Okay. The question number 3. The graph of a quadratic polynomial passes through coordinate points negative of 3, 0, negative of 1, negative of 5, negative of 0, negative of 6, 2, 0. Then the zeros of the quadratic polynomial are here y should be equal to 0. See here this one negative of 3, 0 and 2, 0. Here y is equal to 0 and the value of x is negative of 3 and 2. So option D negative of 3 and 2 is correct. In an AP, if an is equal to 2n minus 1, then the common difference is 4 options are given. We have to find which one is correct. Here we have to find A1 and A2. Then you have to subtract A1 from A2. Here A1 is, you put 1 instead of n. 2 into 1 minus 1. What is it? 1. So A1 is equal to 1. A2. Put 2 instead of n. 2 into 2, 4. 4 minus 1. This is 3. So 3 minus 1, it is 2. Option A is correct. The coordinates of the midpoints of the line joining the points negative of 4, 2 and negative of 2, 6 are. The formula is, you have to remember formula, x1 plus x2 by 2 and y1 plus y2 by 2. Here x1 is negative of 4, x2 is negative of 6. If you add, you'll get negative of 6 by 2. That is negative of 3. Definitely I will tell option B is correct. No other options have negative of 3 in the place of x. Okay, let us find y coordinate. 2 plus 6, that is 8 divided by 2, that is 4. So option B is correct. The next question, if tan theta is equal to 1, then the value of secant theta is. There are two approaches for this question. One is, if tan theta is equal to 1, tan square theta is equal to 1, yeah, squaring on both sides. That is equal to tan square theta is equal to secant square theta minus 1. Secant square theta is equal to transpose negative of 1 to this place. So secant square theta is equal to 2. So secant theta is equal to square root of 2. If you are not interested in solving this type, okay, there is another option also. How do you do? Tan theta is equal to 1. Then tan theta is equal to 45, you know, isn't it? Secant 45, that is equal to square root of 2, because it is the reciprocal ratio of cos theta. Cos 45 is 1 by square root of 2. Take the inverse of this, that is square root of 2. Option C is correct. In the figure, a toy is made up of a cone mounted on a sphere shown in the figure. Then the formula to find out the volume of the toy. Volume of cone, what is it? 1 by 3 pi r square h, plus volume of hemisphere, what it is? 2 by 3 pi r cube. So option C is correct. If the probability of losing a game is 0.25, then the probability of winning the same game is, total probability is 1, isn't it? 1 minus 0.25. What it is? 0.75. So option B is correct. Write the HCF of 7 and 12. There are how many questions? 8 questions. Each carries 1 mark. Okay, 1 mark questions. Second main. Write the HCF of 7 and 12. Here observe, 7 and 12 are co-prime numbers. Always co-prime numbers, HCF of co-prime numbers is always 1. So answer is 1. Write the general form of a quadratic polynomial where a, b and c are real numbers and x is a variable. The answer is ax square plus bx plus c. The next question, 11th one. Write the formula to find the area of a quadrant of a circle. 1 by 4 pi r square. Write the formula to find the volume of a cylinder whose radius is r and height is h. Pi r square h is the answer. What does L represent in the formula for median? L plus n by 2 minus Cf upon F into H. Here L is lower limit of the median class. Now the 14th question. In the following figure, ABC is a triangle in which DE is parallel BC. Observe the figure. DE is parallel BC. AD 1.5, it is given in the figure. BD 3 cm, AE is 1 cm. Then find the value of EC. If a line is parallel to one side of the triangle, then it divides the other two triangles in the same ratio. So AD by DB is equal to AE by EC. Look at the figure and write. AD is how much? 1.5. BD is 3, that is equal to AE is 1 by EC. By cross multiplication, we know that EC is equal to 3 by 1.5, which is equal to 2. So EC is equal to 2 centimeter. The next question. In the following figure, this is the figure, observe. O is the center. Here is O. AB is a tangent. This is tangent at P. Here angle, this one, BPQ is 50 degree. Then find the angle POQ. This angle you have to find. You know that. We all know. What? Tangent and perpendicular to radius are perpendicular to each other. We know that angle OPB is 90 degree. Why? At the point of contact, radius and tangents are perpendicular. So, angle QPO is equal to 90 minus 50, that is 40 degree. Since radii are equal, OPQ is an isosceles triangle. So this angle is also is equal to this angles. Angle opposite to equal sides, 40 degree, 40 degree. 40 plus 40, 80, 180 minus 80. Why that is so? Angle sum property. Sum of all the angles of a triangle 180 degree. So angle O is equal to 180 degree, 100 degree, 180 minus 80, 100 degree. So angle POQ is 100 degree. Find the class mark in a class interval 10 to 25. You know that class mark is the average of the two numbers, upper limit plus lower limit divided by 2, or lower limit by plus upper limit divided by 2. So 10 plus 25 by 2, that is 35 by 2, that is equal to 17.5. Now let us solve the third question. Answer the following questions. There are 8 questions of 2 marks each, totally 16 marks. 17th question. In the given figure has been given here. Find the value of cos A and cosecant C. Here, a right angle triangle ABC is given. Here, angle B is 90 degree. Observe the figure. So, cos A, Ca, C, A, H. Adjacent side by hypotenuse. This is angle A, this is adjacent side, this is hypotenuse. So, it is equal to AB by AC. We know that cos theta is equal to adjacent by hypotenuse. So cos A. AB is how much? 1. AC is root 2. So cos A is 1 by root 2. This is the answer. Sin C. Why are we looking for sin C? They have asked us to find cosecant C. Cosecant C is equal to 1 by sin C. Cosecant and sine are reciprocal ratios. So now let us find sine ratio. So opposite by hypotenuse. For angle C, this is angle C. Opposite side is AB, hypotenuse is the same, AC. So sin C is equal to AB by AC. Here AB is equal to how much? 1, AC is root 2. So sin C is equal to 1 by root 2. We know that cosecant C is equal to, here we can say that cosecant C is equal to root 2. Why? Cosecant C is equal to 1 by sin C. Now 18th question. Solve 2x plus y is equal to 8, 3x minus y is equal to 7. So the given equations are 2x plus y is equal to 8. This is the equation number 1. 3x minus y is equal to 7. This is equation number 2. Here observe that y has the same coefficient with the different signs. So now we can solve it by elimination method. Now equation number 1 and 2 we have to add 2x plus 3x, that is 5x. This and this get cancels. 8 plus 7, this is 15. So x is equal to 15 by 5, that is equal to 3. So x is equal to 3. Now put x is equal to 3 in equation number 2, or you can put it in equation number 1 also, no problem. 3 into 3, instead of x you have to put 3 minus y is equal to 7. 3 3s are 9. So minus y is equal to transpose 9 to this place. 7 minus 9. So minus y is equal to minus 2. So y is equal to 2. So x is equal to 3 and y is equal to 2. Now let us solve 19th question. There are two internal choice questions. The questions are taken from the chapter Arithmetic Progression. Find how many two-digit numbers are divisible by 5 using the formula. Or an arithmetic progression consists of 20 terms whose first and last terms are 12 and 106 respectively. Find the sum of the progression. Now let us solve the first one. Find how many two-digit numbers are divisible by 5 using formula. Here two-digit numbers are 10, 11, 12, isn't it? But the numbers should be divisible by what? 5. So first number is 10, 15, 20, 25 and so on. The last number is 95 because 100 is 3-digit number. Now here A first term is 10, D common difference 15 minus 10 that is 5. We have to find number of terms. We are also given that nth term, last term is 95. Nth term of an AP is an is equal to a plus n minus 1 into d. Now let us substitute the values. Instead of an 95, a 10, n we don't know, we have to find. D is 5. Now transpose 10 to this side. What will you get? 95 minus 10 is equal to n minus 1 into 5. 95 minus 10 is 85 is equal to n minus 1 into 5. Now transpose 5 to this side. So n minus 1 is equal to 85 by 5, which is equal to 17. So n is equal to transpose 1 to this side. N is equal to 17 plus 1, that is 18. So the number of terms is 18. Now let us solve the next question. An arithmetic progression consists of 20 terms whose first and last terms are 12 and 106 respectively. Find the sum of the progression. We have to find the sum of the progression. Sum of n terms of an AP when first term and last term are given is Sn is equal to n by 2 into a plus l. Now let us substitute the values. Before that, let us collect all the given items. Here a is 12. It is here. L is 106. N is 20. Look at the problem also. Now let us substitute. So Sn is equal to Instead of n, 20, a, 12, l, 106 you have to substitute. 20 by 2 is 10, 12 plus 106, 118. So 10 into 118, that is equal to 1180. Sum of 20 terms of the progression is 1180. Now the 20th question, solve x minus 3 by x is equal to 2. This is clearly a quadratic equation problem. Now let us solve. The given equation is x minus 3 by x is equal to 2. Now take LCM. LCM is x. So it becomes x square minus 3 is equal to 2x because LCM is x. Then write in the standard form x square minus 2x minus 3 is equal to 0. Now we can solve this equation either by factorization method or by formula method. Now let us solve it by factorization method. Here C is 3, isn't it? Can be factorized like this. 3 into 1 is 3. Bigger number sign is negative. So minus 3 plus 1 is equal to minus 2. Minus 3 plus 1 is equal to minus 3. So now let us write it like this. X square plus x minus 3x plus 3 is equal to 0. Splitting the middle term. Now group like this. Here in this group x is common. In this group is negative of 3 is common. So x into x plus 1 minus 3 into x plus 1 is equal to 0. Here x plus 1 is common. X plus 1 into x minus 3 is equal to 0. So x plus 1 is equal to 0 or x minus 3 is equal to 0. So x is equal to minus 1, transpose this to this side, or x is equal to 3. So the solution of x minus 3 by x is equal to 2 is x is equal to minus 1 or x is equal to 3. Now the 21st question, find the coordinates of the point which divides the join of line joining the points. Okay. 1, 6 and 4, 3 in the ratio 1 is to 2. This question is taken from the chapter coordinate geometry. Section formula is used here. Let the coordinates of the point P, xy, which divides the line segment joining the points A 1, 6 and B 4, 3 in the ratio 1 is to 2. So coordinates of the point P x, y is given by the section formula x is equal to m1 x2 plus m2 x1 upon m1 plus m2 and y is equal to m1 y2 plus m2 y1 upon m1 plus m2. Here x is equal to 1. Here see, x is equal to 1, x1 is equal to 1, x2, y1 is equal to 6, x2 is equal to 4, y2 is 3, m1 is 1, m2 is 2. Now let us substitute the values in the section formula. So x is equal to 1 into 4 plus 2 into 1 upon 1 plus 2. What happens? And also y is equal to 1 into 3 plus 2 into 6 upon 1 plus 2. Now let us solve this one. X is equal to 1 into 4 is 4, 2 into 1 is 2 upon 1 plus 2 is 3. 4 plus 2 is 6, 6 by 3. So x is equal to 2. Now let us solve this one. 1 into 3 is 3, 2 into 6 is 12. So y is equal to 3 plus 12 by 3. So y is equal to 3 plus 12 is 15 by 3. So y is equal to 5. Therefore, the coordinates of the point P are 2, 5. Now the 22nd question. A bag contains some cards of consecutive natural numbers from 1. They didn't tell up to which number. Up to 100 or up to 1000 or up to million. They didn't tell. Let it be. If the probability of drawing an even natural number card is 4 by 9, then find the probability of getting prime number card. Is it difficult? No, not at all. Now let us solve. Here P of A is given. What is it? Probability of event, that is drawing even natural number, let it be P of A. It is 4 by 9. So here P of A is also is equal to number of A upon number of S. Here tally, number of A is 4, number of S is 9. So number of S is 9. Possible outcomes what? From 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Here the prime numbers 2, 3, 5, 7. Then let E be the event of drawing prime number. So number of E is 4. P of E is equal to number of E upon number of S. Number of E is 4, number of S is 9. So P of E is 4 by 9. Now let us solve the 23rd question. There are internal choice question for this one. Now let us solve this question. Now let us solve this question. In the given figure, ABCD is a trapezium in which AB parallel CD. This one. Look at the figure. And its diagonals intersect at O. This is at this point. AC and BD intersect at O. Show that AO divided by BO is equal to CO divided by DO. Now let us have the figure. What has been given here? ABCD is a trapezium. AB parallel, this one, look at the figure, CD. AC and BD intersect at O. To prove AO by BO is equal to CO by DO. Construction. Draw OE parallel CD. This one and this one parallel, such that E lies on BC. Now we have the figure. Proof. In triangle BDC, observe. Now we are proving this by basic proportionality theorem. We can also prove this by similarity by using angle similarity criterions. Two triangles AOB and COD are similar. We can prove and hence proved. The result can be proved. Okay. In a triangle BDC, observe where it is. This one. Observe the figure BDC. Here OE is parallel to CD. Why? It is by construction. We have drawn EO parallel CD. So this triangle, according to basic proportionality theorem, what happens? BO by OD is equal to BE by AC. Look at the figure and write. Let this be equation number 1. Because of basic proportionality theorem, in triangle ABC, this triangle ABC, let me show it in a different color. This triangle ABC. Here EO parallel AB. It is also by construction. So what happens? AO by, where is AO? AO by OC is equal to BE by EC. We can write. Let this be equation number 2. Because of basic proportionality theorem. Corollary of basic proportionality theorem also we can write. Okay. Now, from 1 and 2, observe BO, BE by EC. This RHS part of equation 1 and 2 are equal. Then LHS part should be equal. AO by OC is equal to BO by OD. Now transpose BO to this side and OC to this side. So AO by BO is equal to CO by DO. Hence proved. Or you can also solve this one in the given figure. This is the figure. LM parallel. This is LM. Look at the figure. CB. And LN parallel CD. Prove that AM by AB is equal to AN by ND. Now, let us have the figure. Once again, what has been given here? LM parallel CB, LN parallel CD. To prove AM by AB is equal to AN by AD. Now in triangle ABC, this is triangle ABC. Observe the figure carefully. What has been given? It is given that LM is parallel to CB. So according to basic proportionality theorem or corollary of basic proportionality theorem, what happens? AM by MB is equal to AL by AC. Why? Because of BPT or corollary of BPT. Both you can write. Let this be equation number 1. Now in triangle ACD, this triangle, what has been given here? LN parallel CD. So AN by AD is equal to AL by AC. This is also because of BPT or corollary of BPT. Let this be equation number 2. Now observe equation number 1, RHS of equation number 1 and RHS of equation number 2. They are equal to each other. Then LHS should be equal. So AM by AB is equal to AN by AD. Why? From 1 and 2. Hence proved. Now let us solve the 24th question. Find the value of the discriminant of the quadratic equation 3x square minus 7x plus 4 is equal to 0 and also write the nature of the roots. Here the given equation is 3x square minus 7x plus 4 is equal to 0, which is in the standard form. Here a is equal to 3, b is equal to negative of 7, c is equal to 4. Discriminant d is equal to, because we have to find the discriminant of the equation, b square minus 4ac. Now let us substitute the values. B is negative of 7, so negative of 7 square, 4, A is 3, C is 4. Here negative of 7 square is 49, 4 into 3, 12, 12 into 4, 48. So this is equal to 49 minus 48, which is equal to 1. Since the discriminant is greater than 0, that is equal to 1. The given quadratic equation will have two real distinct roots. Here we have completed all the 2 marks questions. Now let us solve the fourth main question, which carries 9 questions of 3 marks each, totally 27 marks. Now 25th question, prove that square root of 5 is an irrational number. This type questions are very important and very easy. Please follow. Let us assume to the contrary that square root of 5 is a rational number. We know that rational numbers are those numbers which are expressed in the form of a by b, where a and b are integers and b is not equal to 0. Hence, we can write square root of 5 is equal to a by b, where a and b are integers with no factors in common. So, b square root of, now we can multiply these two, isn't it? B square root of 5 is equal to a. Now squaring on both sides, we get, and rearrangement, 5b square is equal to a square. What do we get? 5b square is equal to a square. Therefore, a square is divisible by 5. We can bring 5 here, no? By theorem 1.3, it follows that a is also divisible by 5. So we can write a is equal to 5c for some integer c. Substituting for a instead of a here, let us substitute what? 5c. So 5b square is equal to 5, instead of a we have to write 5c the whole square. So 5b square is equal to 5 square is 25, c square. Bring 5 to this side. What happens? B square is equal to 5c square. This means b square is divisible by 5, and so b is also divisible by 5. This means that b is divisible by 5, so b is also divisible by 5 once again. Therefore, a and b have at least 5 as a common factor. But this contradicts the fact that a and b are co-prime. This contradiction has arisen because of our incorrect assumption that square root of 5 is rational. So we conclude that square root of 5 is irrational, hence proved. Now the 26th question, which is taken from the chapter Polynomials. The question is, if zeros of a quadratic polynomial are -3 and 4 respectively, then find the quadratic polynomial and also verify the relationship between the zeros and coefficients. There is an alternative for this question, or alpha and beta are the zeros of the quadratic polynomial. If alpha plus beta is equal to negative of 3 and alpha into beta is 2, find the quadratic polynomial and also find the value of alpha minus beta. Now let us solve this question. If the zeros of the quadratic polynomial are negative of 3 and 4 respectively, alpha is equal to negative of 3 and beta is equal to 4. Find the quadratic polynomial. So now we have to use the formula x square minus alpha plus beta, sum of the roots, into x plus alpha into beta, means product of the roots. Now we have alpha plus beta. Alpha is negative of 3, beta is 4. So sum of the roots is negative of 3 plus 4, that is equal to 1. Alpha into beta, negative of 3 into 4, that is equal to negative of 12. Now let us substitute the values in the formula. Formula, you already know it. You have to write which carries marks. Okay. X square minus alpha plus beta into x plus alpha into beta. Now let us substitute the values. Alpha plus beta is 1. So we have to put the value 1 here. Alpha into beta is negative of 12. So now solve. Negative of 1, negative into 1, that is negative of 1. So it implies that x square minus x minus 12 is the required polynomial. So x square minus x minus 12 is the required polynomial whose zeros are negative of 3 and 4. Now let us verify the relationship between the zeros and coefficients of the polynomial. We know that sum of the zeros minus means negative of b by a. Okay, here b is 1, isn't it? Now let us substitute the values. Actually the sum of the zeros, what it is? Negative of 3 plus 4, that is 1. b by a is equal to negative of 1. Here b is negative of 1 by 1, that is 1. And this are equal, isn't it? 1, let this be 1, and this be equation number 2. From 1 and 2, the relationship between the coefficients and zeros is verified. We know that product of the zeros is c by a. Product of the zeros, alpha is negative of 3, beta is 4. 4 into negative of 3 is negative of 12. C by a, here c is negative of 12, a is 1, that is equal to negative of 12. Let this be equation number 3, this be equation number 4. From 3 and 4, the relationship between the coefficients and zeros is verified. There is an internal choice question for this one. Alpha and beta are the zeros of a quadratic polynomial. If alpha plus beta, sum of the roots is given negative of 3 and product of the roots, that is alpha into beta, is 2, then find quadratic polynomial and also find the value of alpha minus beta. Here two questions are there. One is to write the quadratic polynomial, another one is to find the value of alpha minus beta. Quadratic polynomial is of the form of x square minus sum of the roots into x plus product of the roots. Here sum and product are given, so sum is negative of 3, product is 2. Let us substitute the values in the formula. X square minus alpha plus beta into x plus alpha into beta. Alpha plus beta is negative of 3, alpha into beta is 2. Here minus into minus, that is plus. So it implies that it is equal to x square plus 3x plus 2 is the required polynomial. Now still another question is there. We have to find alpha minus beta. Now let us recollect from our memory that we can use one identity. Uh, Alpha plus beta the whole square minus 4 into alpha into beta, that is equal to alpha minus beta we will get. Let us check if you want. Alpha square plus beta square plus 2 alpha beta minus 4 alpha beta, which is equal to alpha square plus beta square minus 2 alpha into beta, that is equal to alpha minus beta the whole square. This you should remember. Okay, now this is only the rough work. I have done it to make you to understand. Okay. Now let us find the value of alpha minus beta. Alpha minus beta the whole square is equal to alpha plus beta the whole square minus 4 into alpha into beta. Here alpha plus beta is given, isn't it? What is it? Negative of 3. Now let us substitute the value. Alpha into beta is 2. So minus 4 into 2. Negative of 3 square is 9 minus 4 into 8 is minus 8. 9 minus 8 is equal to 1. This is equal to alpha minus beta the whole square, isn't it? So alpha into beta is equal to plus or minus root of 1. So alpha minus beta is equal to plus or minus 1. Now let us solve 27th question, which is taken from the chapter trigonometry. Now let us solve this one. Find the value of 5 cos square 60 plus 4 secant square 30 minus tan square 45 upon sin square 30 plus cos square 30. Okay, if you have left hand and 5 fingers, you can easily solve it. You know all the hand tricks, isn't it? Okay, now let us write the question once again. Here 5 into cos 60 is 1 by 2, the square. Then 4 into secant square 30. It is the reciprocal value of cos 30. Cos 30 is root 3 by 2. So secant square 30 is 2 by root 3, the square. Minus tan square 45. Tan 45 is 1. Tan square 45 is also 1. Sin square 30. It is half, the square. Cos square 30. Root 3 by 2, the square. So now what to do? Let us substitute the values. We have taken all the values. We know all the values. So now let us substitute. We have substituted, then expand it. You know how to expand it. 1 by 2 the whole square is equal to 1 by 4, isn't it? This one. 2 by root 3 the whole square is 4 by 3, this one. 1 the square is 1, 1 by 2 the square is 1 by 4. Root 3 by 2 the square is 3 by 4. So now expand it, and these are all scribbling one. You have to write it neatly like this. Then what will you do? 5 into 1 by 4. What it is? 5 by 4. 4 into 4 by 3 is 16 by 3 minus 1. 1 by 4 plus this is 3 by 4. Here 5 LCM is, what is the LCM of numerator? LCM is 12. So now for the numerator, for the denominator LCM is 4. So we can write like this. 12 is the LCM of numerator. 4 3s are 5 3s are 15. 3 4s are 16, 4s are 64. 1 into 12 minus 12, or you can keep it like 1 and then solve, no need to worry. 1 by 4 plus 3 by 4, LCM is 4, so it is 4 by 4, it is 1. Okay, now you can solve the numerator only because in the denominator 1 is there, that is equal to 67 by 12. How? 15 plus 64, what it is? 74 minus 12, 67. 67 by 12 is the answer. These are all LCM you have to write in the book, otherwise mark will be. LCM of denominator is 12. LCM of numerator is 12. LCM of denominator is 4. Okay. Now let us solve this question. Prove that 1 plus secant A by secant A is equal to sin square A upon 1 minus cos A. The problem is 1 plus secant A by secant A is equal to sin square A upon 1 minus cos A. Here LHS is what? 1 plus secant A upon secant A. That is equal to, here separate it, 1 by secant A plus secant A by secant A, that is equal to 1. 1 by secant A is cos A plus 1. Now let this be equation number 1. Now RHS is sin square A by 1 minus cos A, which is equal to sin square A is equal to 1 minus cos square A. Why? By Pythagorean identity. Sin square A plus cos square A is equal to 1 by this one. Now in the numerator, what will you write? 1 plus cos A into 1 minus cos A, isn't it? Why? It is in the form of A square minus B square. By using this identity, what it is? A plus B into A minus B. We can write it as 1 plus cos A into 1 minus cos A. Here observe, this and this get cancels. Answer is 1 plus cos A. Let this be equation number 2. From 1 and 2, 1 you remember no, what it is. LHS is equal to RHS, hence proved. Now let us solve 28th question, which is taken from the chapter Coordinate Geometry. Find the area of the rhombus ABCD whose coordinates of the vertices are A 2, 4, C 8, 12 and length of BD is 5 units. Now let us have a rhombus ABCD with the A coordinate 2, 4, B we don't know, C 8, 12, D coordinates we don't know, but the diagonal BD is equal to 5 units. We have to find the area of the rhombus. We know area of the rhombus is equal to half into product of diagonals. One diagonal, that is BD, we know it is 5 units. But we have to find the length of the diagonal AC. How can we find it? By use, they have given us the coordinates, isn't it? A 2, 4, C 8, 12. The length of the diagonal AC can be found out by using the distance formula, that is D is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let this coordinate this be x2 y2, this one x1 comma y1. Okay. Now let us substitute the values. This one is x2 y2, this one is x1 y1. Let us keep that solved. Okay, now let us substitute the values. AC is equal to square root of 8 minus 2 the whole square plus 12 minus 4 the whole square, which is equal to 8 minus 2 is 6, 12 minus 4 is 8. So 6 square plus 8 square. 6 square is 36, 8 square is 64. If we add 36 and 64, we will get AC is equal to square root of 100. So AC is equal to square root of 100, that is 10 units. Now we have to find the area of the rhombus, which is equal to half into product of the diagonals. Here the diagonals are BD and AC. BD we have been given and AC we have find it out. So half into 5 into 10. Half, 2 ones are 2, 5s are 5 5s are 25. So area of the rhombus is 25 square units. Now let us solve 29th question, which is taken from the chapter Statistics. Here two questions are there. You can solve either of the one. First one is to find the mean, second one is to find the mode. Okay, now let us find the mean for the following data. Now let us make two columns, two vertical columns, and write class interval in the first one and frequency in the second one. Now let us add these data 5 to 15, 6 frequency, like that. Go on writing. Now let us add one more column to find mean, not a midpoint or class mark or x dash of the class interval. 5 plus 15, what it is? 20. 20 by 2, it is 10. Then you can add size of the class interval also. What is the size here? 10. 10 plus 10, 20. Or you can add these two and divide by 2. Both are correct. 20 plus 10, 30. 30 plus 10, 40. 40 plus 10, 50. Here you can't add because 55, 66. You have to add these two and divided by 2. You'll get what? 60.5. Then add one more column for Fi Xi, means you have to multiply these two numbers and write it in the column. 6 into 10, what it is? 60. 11 into 20. 21 into 30, 23 into 40, 14 into 50, 5 into 60.5, 60.5, 302.5. Now you have to add all these numbers to get what? Summation of Fi, that is 80. If you add 6 plus 11 plus 21 plus 23 plus 14 plus 5 is equal to 8. Then you have to all these numbers. You will get what? Summation of Fi Xi, 2832.5. So now you can find mean with this data. Mean is equal to summation of fi xi upon summation of fi. Substitute the values 2832.5 by 80. What it is? 35.4. So mean of the data is 35.4. Or you can find the mode of the data. Here let us write in columns, 2 columns, class interval in the first one, frequency in the second one. It has been given in the textbook also. Now from the table it can be observed that maximum class frequency is 61, this one, isn't it? Belonging to the class interval 60 to 80, this one. Now therefore modal class is 60 to 80. Lower limit of the modal class L is equal to 60. Frequency of the modal class F1 is 61. Frequency of the class preceding the modal class F0 is 52. Frequency of the class succeeding the modal class F2 is 38. Class size, you know how to get it. 80 minus 60, it is 20. So mode is formula. It is very necessary to write the formula. L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. Now let us substitute the values. L is 60, F1 is 61, F0 is 52. 2 into F1 is 61, F0 is 52, F2 is 38 into 20. H is 20. Now we have these values. Solve it. That's all. Mode is equal to 60 plus 61 minus 52. Here 2 into 61. Here you can add these two numbers with the negative sign. You'll get like this: 9 by 122 minus 90 into 20. Now further solve it. 122 minus 90. What it is? 60 plus 9 by 32 into 20. Here 4 5s are 4 8s are. Now further solve it. You will get 60 plus 45. 9 5s are 45 by 8. So mode is equal to 60 plus this one is 5.625. So mode is equal to 60 plus 5.625, that is equal to 65.625. This is the answer. Now the 30th question. If D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC, show that CA square is equal to CB into CD. This is also a textbook question. This question is taken from the chapter triangles. This question is based on angle similarity criteria. Okay, now figure is not been given, so now let us have a figure. What is given here? A triangle ABC. Now let us have a triangle ABC, and also we are given what? D is a point on the side BC. This is BC, here D is there, name it as D, join AD, and it is also given that angle ADC, this is angle ADC, is equal to angle BAC. This one. And to prove CA square is equal to CB into CD. Now in triangle ABC, observe bigger triangle, this one ABC, and triangle DAC, this one you have to take. Angle ADC is equal to angle BAC. It is given angle ACB is equal to angle ACD, this angle. Why? It is common to both triangles. So triangle ABC is similar to triangle DAC. Why? Because of angle criterion. If two triangles are similar, then their corresponding sides are proportional, isn't it? Now, so we have CA by CD is equal to CB by CA. CA, this is bigger triangle ABC, by CD, the part of the smaller triangle, is equal to CB, is the part of bigger triangle, by CA, this is the part of smaller triangle. Now cross multiply. What do you get? CA square is equal to CB into CD, cross multiplication. This is what we wanted to prove, hence proved. Now the 31st question, which is taken from the chapter circles. It is an important theorem, you should not leave it. Okay, what is that question? Prove that the lengths of the tangents drawn from an external point to a circle are equal. What is the data? A circle with center O, PQ and PR are the tangents. PQ and PR. This point is P, this one is Q, this one is R. Now we have the figure. To prove, what is to prove? PQ is equal to PR. Length of the tangents are equal. So, construction. Join OP, OQ and OR. Now we have two triangles. What are they? Triangle PQO and triangle PRO. Here angle PQO, this angle is equal to angle PRO, this angle, that is equal to 90 degree. Why? At the point of contact, radius and tangents are perpendicular. So now OP is equal to OP, this one. It is common to both triangles, and OQ is equal, look at the figure, OQ is equal to OR by radii of the same circle. Here we can observe that triangle PQO is congruent to triangle PRO. Why? Because of this is right angle, this is hypotenuse, look at the figure, and this is side. Okay. Right angle, hypotenuse, side. Why? Because of RHS rule, they are congruent. So PQ is equal to this one is equal to PR, corresponding part of congruent triangle, hence proved. So the tangents are equal. Now let us solve 32nd question, which is taken from the chapter quadratic equations. The age of father is 30 years more than his son. After 5 years, the product of their ages is 400. Find the present ages of both son and father. There is an alternative for this question. The first number is 3 more than the second number. The sum of their squares is 29. Find the numbers. Now let us solve this question. Let the age of the sun be x years. We have to find the present age. We have to write here present age. Okay. Age of present age of father 30 years more than his son. So x plus 30 years present age of father. After 5 years, here see 5 years, age of the son is x plus 5. Age of father 30, x plus 30, x plus 30 plus 5. So x plus 35 years. According to the given condition, product of their ages after 5 years is 400. So present after 5 years, age of son is x plus 5. Age of father is x plus 35. That is equal to 400. Now we can multiply these two numbers by using the identity x plus a into x plus b is equal to x square plus a plus b into x plus ab. You know it, isn't it? I am simply recollecting all those things here. Now, once again, x square plus 40x, this plus this into this 175 is equal to 400. Now let us write the standard form, means we have to bring 400 to this side. Then it becomes negative 175 minus 400, that is equal to negative of 225, that is equal to 0. So now the equation is x square plus 40x minus 225 is equal to 0. Now let us solve it by factorization method or by formula method. Okay, now let us solve it by factorization method. Now we have to find two numbers such as their product is negative of 225, sum is positive 40. Okay, now so those numbers are negative of 5, positive of 45. So now it becomes x square minus 5x plus 45x minus 225 is equal to 0. Now let us group this and this. Here x is common, here 45 is common. So now this becomes x into x minus 5 plus 45 into x minus 5 is equal to 0. X minus 5 is common, so now it becomes x minus 5 into x plus 45 is equal to 0. So x is equal to 5 or x is equal to negative of 45. But age of a person cannot be negative. So age of the sun is 5. X is equal to 5. So age of the son is how much? 5 years. Age of the father is 5 plus 30 years means 35 years. Okay. Now let us solve the alternative question. The first number is 3 more than the second number. The sum of their squares is 29. Find the numbers. As usual, let the second number be. Here, second number is simpler. The first number is 3 more than the second number. So now we have to keep the second number as x. Now the first number is what? X plus 3. According to the question, what happens? Sum of their squares means x square plus x plus 3 the whole square is equal to how much? 29. So expand this by using a plus b whole square formula, that is equal to a square plus 2ab plus b square. Okay. Now so it becomes what? X square plus 6x plus 9 is equal to 29. Now write it in the standard form, means you have to bring this to this place it becomes negative of 29, and you can add these two. So 2x square plus x minus 20 is equal to 0. Here 2 is common, observe, so take it outside. X square plus 3x minus 10 is equal to 0. Now factorize minus 10 as the product plus 5 minus 2. If you add, you'll get negative of 3. If you multiply, you'll get of not negative, positive of 3. If you add, multiply, you'll get positive of 10. So x plus 5 into x minus 2 is equal to 0. Here directly you can write, the numbers, no? X is equal to negative of 5. Here negative, observe. So, and x is equal to 2. If you transpose negative of 2 to that place, it becomes 2. So, we know that x is equal to negative of 5 or x is equal to 2. So, the second number is negative of 5 or 2. The first number is, you have to add 3 to both negative of 5 and positive of 2. What will you get? If you add 3 to this, you'll get negative of 2. If you add these two, you'll get 5. So the numbers are, we have already written the numbers, so don't worry. Minus 5 or 2, the first number, second number is minus 2 or 5. Okay. Now let us solve 33rd question, which is taken from the chapter Areas Related to Circle. In the figure, O is the center of the circle, this one. Area of a sector AOB, this one, AOB. Look at the figure also. Is to area of the circle is 1:5. If the radius of the circle is 7 centimeter, then find the length of the arc AB. Okay, what has been given here? Area of a sector AOB is to area of circle is 1:5. The radius of the circle is 7 centimeter. To find the length of the arc AB. Now let us find the length of the arc AB. Before that, we are given that area of sector AOB is to area of circle is 1:5. Okay, area of sector formula is theta by 360 into pi r square. Area of circle is pi r square. Now let us substitute the values. Area of sector AOB upon area of circle. So this is area of sector AOB. This is area of circle. Theta by 360 into pi r square upon pi r square is equal to 1 by 5. Pi r square and pi r square get cancels here. So what we get, theta by 360 is equal to 1 upon 5. 5 ones are denominator and denominator can get cancels, isn't it? So theta is equal to how much? 72 degree. So now we have got here, this one is 72 degree, this one 7 centimeter. With this knowledge we can calculate the length of arc AB. Formula for the arc of the sector is theta by 360 into 2 pi r. Now let us substitute the values. Theta is 72. Radius is 7. Pi is 22 by 7. Here 72 5's are 360. 7 and 7 get cancels. So now we have how much? 2 into 22, that is 44. 44 by 5. 44 by 5 we get, which is equal to 8.8 centimeter. So length of the arc of the sector is 8.8 centimeter. Now the fifth main question. There are 4 questions which carries 4 marks each, totally 16 marks. Now the 14th question, which belongs to the chapter a pair of linear equations solving by graphical method. A compulsory question in each and every question paper it appears, so practice it thoroughly. Solve the following pair of linear equations in 2 variables by graphical method. The first equation is x plus 2y is equal to 8. The second equation is x plus y is equal to 5. Now the given equations are, you have to write in the answer page. Okay, now let us form table for values of x and y. If x is equal to 0, then for this equation, for the first equation, x is equal to 0, then 2y is equal to 8, isn't it? Oral problems only you can do. 4. When x is equal to 2, if you put odd number, what happens? Here also 2y is equal to minus 7, 7 it comes, then you'll get answers in fractions. It will be difficult, not so, but to some extent difficult. Counting the numbers, putting the points, everything. So if it x is 2, then what happens? 8 minus 2, 6. 2y is equal to 6. Then 6 by 2 is 3. When x is equal to 4, y is equal to 2. In the similar manner, we have to create a table of values for x and y for the second equation. This is pretty good because both are do not have any coefficients, and this is odd number. Okay, but when x is equal to 1, if I put x is equal to 0, y will become 5, and graph sheet, our graph sheet does not contain 4. We have to make special arrangements for that one, so I didn't put 0, that's all. Okay, now y is equal to 4. When x is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 2. Here observe 2, 3. 2, 3. This and this have the same value. So solution is 2, 3. X is equal to 2, y is equal to 3. See, observe. 2 into 3, 6. It is 8. It is true. Here 2. This one is 3, 5. So we got our answer. This is only rough work for your reference. That's all. We need not do it in the answer paper. Now let us take a graph sheet. Scale also you have to write. X-axis 1 centimeter 1 unit, y-axis 1 centimeter 1 unit. Let us have the table of values for x and y here also. First one is 0, 4. The second one is 2, 3. You know how to. 1, 2. Here 3. Y is equal to 1, 1, 2, 3. Okay, 2, 3, 4, 2. Join the points with the line. passes through all the points. This represents the equation x plus 2y is equal to 8. 1, 4, 2, 3, 3, 2 are the coordinates of the second equation. Let us represent it in the graph sheet. And now join the points with the line which represents the equation x plus y is equal to 5. Here both lines intersect. Here x is equal to 2, y is equal to how much? 3. So now x is equal to 2, y is equal to 3 is the solution of the equations. Now the 35th question, which is taken from the chapter Applications to Trigonometry. Okay, figure has been given. Oh, well and good. Now let us read the problem. Two poles of equal heights are standing vertically on a horizontal ground as shown in the figure. We have to see the figure. A, B and C, D are the poles. They are equal to each other. A, B is equal to C, D. Wires are tied from the top of the poles to a peg on the ground. Here is a peg. Let us name it as M. Okay. From A, AM rope, from C, CM ropes are tied. This angle is 60 degree, this angle is, look at the figure, 30 degree. Don't get confused here. 30 has been given first, means our hand goes here only. This is 30, but it is not 30, it is 60, because I have done the same mistake while solving. Then I corrected it. Okay, this is 30. If the distance between the feet of the poles is 100 meter, this is full length 100 meter. Find the height of the poles and length of the wires. We have to find AB and CD and also AM and CM. Now, what has been given? We have to write. If you don't write also, it is okay. It is not the problem. Okay. Now, AB and CD be the poles. Angle AMB is 60 degree. Angle CMD is 30 degree. BD is equal to BD is equal to 100 meter. To find AB, height of the pole AB, which is also equal to the height of the pole CD. So if you find any one of these, the other one will be good. So I have a trick here. Okay, I won't mention here only. AM, rope AM we have, and also BM. Okay. Now here, this is the trick I am telling. AB is equal to CD is equal to H meter. If you don't take it as H, every time you have to write A, B, C, D, it will be cumbersome. So I have written this thing. Another trick is also there. I will mention when the problem comes. Okay. Here let BM is equal to X meter. This one is X. From here to here X. Then DM becomes what? DM, look at the figure. 100 minus X meter. The trick is we don't find X at all. They haven't asked, isn't it? Only they have asked about AB and CD and also AM and CM. Though didn't mention about X at all. So now in right angle triangle ABM, tan 60, observe triangle ABM. AB opposite side, BM adjacent side. Tan 60 is root 3, H by X, which is equal to H by X. Don't write A, B, B, M again and again. In simple words, you can write. Oh, isn't it? Let this be equation number 1. Now, okay, now let us take this as equation number 1. Don't write x in terms of h in terms of x only you write, because we are not bothered about what x, only bothering about h. So h is equal to root 3x. Here now in a right angle triangle CDM, observe the right angle triangle CDM. Tan 30, this one is 30, so the opposite side is CD, adjacent side is MD or DM, one at the same. Tan 30 is 1 by root 3, CD is H, DM is 100 minus X. Okay, now cross multiply. We have to write it in terms of X only. So H is equal to 100 minus X upon root 3. Now let us keep this as what? Equation number 2. Okay. Now we have H is equal to root 3x and H is equal to 100 minus X. This is equation number 1. This is equation number 2. You need not write it again and again. Your time will become wasted while writing. Okay. From 1 and 2 we can write root 3x is equal to 100 minus x by root 3, isn't it? Here cross multiply. What do you get? Root 3 into root 3. What it is? It is 3x is equal to what? 100 minus x. Transpose x to this side. What will you get? 4x. 4x is equal to 100. Then x is equal to 100 by 4. It is 25. So, now substitute. H is equal to root 3x, isn't it? H is equal to root 3x. Here you may get confused. The ma'am told again and again we are not bothering about x. But I am not writing here. I am not using. I am writing directly h. Okay. Root 3x. Instead of root 3, let us write, instead of x, let us write 25. But it is customary to write 25 root 3 meter. So, this is 25 root 3 meter. It is also A, B and CD. Both are equal, isn't it? We have find out the height of the poles. Height of the poles is what? 25 root 3 meter. Now let us find AM, length of the wire AM. How? Here observe in the right angle triangle ABM, sin 60. Here also some persons used cos. If you use cos, you have to find this one. This is okay. Once again we have to find 100 minus x while finding the length of CM. So I have used sine ratio. Sine ratio is opposite by, this is opposite side, hypotenuse. AB by AM. Sin 60 value root 3 by 2. AB is H. Symbolically I have put. We can now directly put the value of that one. Okay. One step is extra here. AM. We have to find AM, isn't it? Instead of H, we have put, this step is extra actually. Okay. 25 root 3 by AM. Here observe, the terms in numerator can be cancelled. Root 3 and root 3 get cancelled. So AM is equal to 50. So length of the wire AM is 50 meter. Now in right angle triangle, which one let us use? CDM, observe the figure. Here also I am using sin 30. CD by CM. Here instead of CD you put H. CM we have to find out. Sin 30 is half. Here H, value of H we know. 25 root 3 substitute. So CM is equal to cross multiply 50 root 3 meter. So length of the wire CM is 50 root 3 meter and this is 50 meter. Okay. So height of the poles is 25 root 3 meter. Once again writing the answer. Length of the wires, which wires? AM is 50 meter and CM is 50 root 3 meter. Now let us solve the 36th question. The question is taken from the chapter Triangles, Theorems on Triangle, one of the important question. Prove that if in two triangles sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar. Now let us solve it. What has been given here? Two triangle ABC and triangle DEF such that AB by DE is equal to BC by EF is equal to AC by DF. Look at the figure and write. To prove angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, and hence the triangle ABC is similar to triangle DEF. Now construction. Cut DP is equal to AB, DQ is equal to AC, join PQ, and proof. Now take, we have been given that AB by DE is equal to AC by DF. AB is equal to DP and Y by construction AC is equal to DQ by construction. So replace AB by DP and AC by DQ. Taking the reciprocals of both LHS and RHS. DE by DP is equal to DF by DQ. Now what will you do? Subtract 1 from both LHS and RHS. Subtract 1 from LHS and RHS. Here DP is the LCM, here DQ is the LCM. So DE minus DP by DP is equal to DF minus DQ by DQ. Look at the figure. DE minus DP, what it is? PE. PE by DP is equal to DF by DQ. Look at the figure. What it is? QF. So QF by DQ. Now once again take the reciprocal of both LHS and RHS. What will you get? dP by PE is equal to dQ by QF. Here observe, dP by PE is equal to dQ by QF. If a line divides any two sides of the triangle in the same ratio, then the line is parallel to the third side. So PQ is parallel to EF. This is from converse of basic proportionality theorem. So angle P is equal to angle E, corresponding angles, this angle, this angle, this angle, this angle. And angle Q is equal to angle F, corresponding angles. In a triangle DPQ and a triangle DEF, look at the figure. What do we have now? Angle P is equal to angle E from 1. Angle Q is equal to angle F from 2. 1, 2, you don't know, it seems. It has been given. Angle P, we have just proved, isn't it? Angle P is equal to angle E, angle Q is equal to angle F. Just now we have proved. It implies that triangle DPQ is similar to triangle DEF. Why? By angle criterion of similarity. It implies that dP by dE is equal to dQ by dF. Look at the figure carefully. That is also is equal to PQ by EF. Why? Let it be equation number 3. Corresponding sides of the similar triangles are in proportion. Now we have equation number 3. dP by dE is equal to dQ by dF is equal to PQ by EF. We are given that AB by DE is equal to BC by EF is equal to AC by DF. Let this be equation number 4. Why it is given? Now observe denominators DE, DE, DF, DF. Here EF, this one is EF. Okay. And DP is equal to AB. This one, this one. DQ is equal to AC. DQ is equal to AC. Why? By construction. So, instead of AB we can write DP. DP by DE. Here, let it be like that only, BC by F is equal to, instead of AC let us write DQ. DQ by DF. Let this be equation number 3 or 5. So BC by EF is equal to this one is equal to PQ by, only these two are remained, isn't it? Other two things are same. This and this and this are same. This and this are same. So remaining things, BF, this BF by E, BC by EF, PQ by EF are same from 3 and 5. Little bit confusion will be there. You practice and understand. Once again I will tell. Here observe this in this equation. Observe dP by dE, BC by EF is equal to dQ. Instead of BC by DF, DQ by DF, this one. Let this be equation number 5. Then what happens? DP by DE, this one. BC by EF, this one, is equal to DQ by DF, this one. Observe 3 and 5. What do you get? Here BC by EF is equal to PQ by EF. This one and this one are equal to each other. So observe BC is equal to PQ. BC is equal to PQ. Now in triangle ABC, observe, and triangle DPQ, we have AB is equal to DP by construction, AC is equal to DQ by construction. Just now we have proved that BC is equal to PQ from 6. It implies that triangle ABC is congruent to triangle DPQ by SSLC criterion of congruency. Now, so what happens? Corresponding parts of the congruent triangles are same, isn't it? Now, angle B is equal to angle P. But now we have already proved that what? Angle E is equal to angle P. So LHS, RHS and RHS are equal. So what happens now? Angle B is equal to angle E. Angle C is equal to angle Q. Corresponding parts of congruent triangle. Observe the figure. But angle F is equal to angle Q. We have proved. So angle C is equal to angle F. LHS and LHS should be equal. So in triangle ABC and triangle DF, angle B is equal to angle E, angle C is equal to angle F. So triangle ABC is similar to triangle DEF. A similarity criterion. Hence proved. Now 37th question. There is an internal choice question for this one. Both questions are taken from the chapter surface areas and volumes. The first option is a sphere of volume 38,808 centimeter cube is divided into two equal parts. Find the total surface area of each hemisphere. Okay, now let us solve. What has been given here? Volume of the sphere, that is equal to 38,808 centimeter cube, which is equal to 4 by 3 pi r cube. We have to find the TSA of the hemisphere, the formula for which is 3 pi r square. Now 4 by 3 pi r cube we have been given. What is that? 38,808 centimeter cube. Now let us substitute the values. For pi, 22 by 7 r cube, that is equal to 38,808 centimeter cube. Now we have to find r cube and then radius. So r cube is equal to transpose 3 to the numerator here, 7 to the numerator, 4 here, 22 here. Here you can observe that The numbers get cancelled, isn't it? 4 ones are 4, 9, 7, 0, 2s are 11 twos are 11, 8s are, then once again 8s are, 2s are. 2 ones are 2, 4, 40, ones are. Here 3 into 7. Here observe that 441. How can you write? 21 square, isn't it? Here once again 7 into 3 is 21. So R cube is equal to 21 cube. R cube is equal to 21 cube. So R is equal to how much? 21 centimeter. So radius of the sphere is 21 centimeter, that which is also the radius of the hemisphere. Now we have to find the TSA of the hemisphere, which is equal to 3 pi r square. Now let us substitute the values. For pi 22 by 7, for radius 21. Now expand. Now let us write 21 as 21 into 21. 7 threes are 3 threes are 9. 9 into 22. 22 into 21. What do you get? 4158 centimeter square. So TSA of the hemisphere is 4158 centimeter square. Now the alternative question, whichever you find easy, you do it. A toy is made up of a cylinder having diameter 10 centimeter. Cylinder like this, its diameter is 10 centimeter. Then let us write it in the given. So radius is how much? 5 centimeter. And height 20 centimeter. H is equal to 20 centimeter. It is joined with the hemisphere of the same diameter at one end. We don't know which end. Okay. This is the hemisphere of same radius, diameter, means its diameter is also 10 centimeter, so radius is 5 centimeter. And at another end we are joined with a cone of equal diameter, means its diameter is also 10 centimeter, so radius is 5 centimeter. And slant height is 13 centimeter. We have to find the surface area of the toy, means total surface area of the toy. Here we have given the shape of the toy with the cylinder in the middle, at the top or one side. We don't know which side. Okay, it has to stand on the ground. Okay. Its slant height is 13 centimeter, cones, and radius of all three items are 5 centimeter. Now we have to find the total surface area of the toy, which is equal to CSA of cone plus CSA of hemisphere plus CSA of cylinder. Okay. Anyway, you can write it. CSA of cone is pi RL. CSA of cylinder is 2 pi RH. CSA of hemisphere is 2 pi R square. Now observe that pi R is common. We can take it out. Here L, then here 2 and H, here 2 and R. 1 R we have taken out, isn't it? So now let us substitute the values. 22 by 7 into 5, L is 13, 2 into H is 2 into 20, plus 2 into R is 2 into 5. Let us do some work here. Let us keep these things like that only. Here 2 into 20 is 40, 2 into 5 is 10. Now if you add all these things, you'll get how much? 63. 7 ones are 7 nines are 63. If you multiply 22 and 5 and 9, you will get 990 centimeter square. So total surface area of the toy is 990 centimeter square. Now let us solve the sixth main part. Here is only one question which carries 5 mark. 38th question. If sum of n terms of an AP is 5n minus n square, then write the arithmetic progression. Also find 21st term and also find the sum of first 21 terms of the progression. Here three different problems are there. First one we have to write the progression, second one write the 21st term, and we have to find sum of 21 terms of the AP. Now let us write the AP first. But before that we have to find A, isn't it? S1, Sn they have given 5n minus n square. S1, that is A, we can find. But to find D, it is little bit difficult. If you remember this formula, An is equal to Sn minus 1. We can find A2, isn't it? A2 means we have to find S1, S2. Okay, now let us find Sn is equal to 5n minus n square they have given. Now let us find the S1. 5 into 1, instead of n we have to put 1, that's all. Square. So S1 is equal to 5 into 1, 5. 5 minus 1, that is equal to 4, which is also is equal to the first term. S2, instead of n put 2, sorry, this one, instead of n put 2. 5 into 2 minus 2 square. So S2 is equal to 5 into 2, 10, 10 minus 4, that is equal to 6. Now we can find A2. How? S2 minus S1 means 6 minus 4, that is equal to 2. Second term is 2. So D, common difference is second term minus first term. Second term is 2, first term is 4. So D is equal to A2 minus A, that is equal to 2 minus 4, that is equal to negative of 2. Now we have A is equal to 4 and D is equal to negative of 2. So AP is 4 comma first term is 4, second term 4 minus 2, that is 2, 2 minus 2, that is 0, 0 minus 2, that is minus 2. This is the AP. Now let us find nth 21st term, that is A21. Here A is equal to 4, D is equal to negative of 2, N is equal to 21. Now let us substitute the values in the formula. Nth term of the AP is An is equal to A plus n minus 1 into D. Now let us substitute. How will you get? See, 20 minus 1, that is 20. 20 into negative of 2 is minus 40. So A21 is minus 40 plus 4, that is negative of 36. So 21st term is negative of 36. Now let us find the sum of n terms of an 21 terms of an AP. How can you find? By using the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. Now let us substitute the values. You know all the values. Okay. Here 2 ones are 2, negative of 16. 21 into negative of 16 is equal to how much? Minus 336. Sum of 21 terms can also be found out by using the formula Sn is equal to n by 2 into a plus l. We know that l is negative of 36, a is 4, n is 21. 21 by 2, a is 4, l is negative of 36. 21 by 2, this is negative of 32. See, this step only came here. 2 ones are 2, negative of 16. 21 into negative of 16. How much we got? S21 is equal to negative of 336. Your convenience. Either of the two methods you can do. Okay, we have finished all the problems here. I hope you have understood all the problems. I have explained it in detail, which is a very time consuming process for me. I have concentrated on each and every step of the sum. If you liked the video, please hit the like button, share and subscribe. Thank you for watching.